Today we're going to talk about dilutions. Oftentimes in chemistry, it's very helpful for us to have concentrated solutions around. And if we need to make solutions that are less concentrated or dilute, we can just water them down or add some water to them. And so this is the most cost-effective way to deal with solutions rather than buying maybe a 0.1 molar, a 0.5 molar, a 1 molar, a 2 molar, a 5 molar solution. Might as well buy some concentrated solution and just water them down yourself. And so that's what we're going to talk about today in dilutions. And so just as a reminder to us, let's talk about molarity really quickly. And remember, molarity quantifies concentrated versus dilute. For example, let's say we have what we call a stock solution. And stock solution is our concentrated solution. Let's say we have some 12 molar, we'll call it hydrochloric acid solution. Now that would be definitely our concentrated solution. There's lots and lots of moles of HCl per 1 liter of solution. Now this would be much more concentrated than, let's say, a 0.5 molar solution of HCl. So we would call this dilute. It has less hydrogen ions and chloride ions in it, where the 12 molar has more. So that's really how we tell the difference between concentrated and dilute, is just that value of the molarity there and there. Okay, so we do have a formula that we're going to use for what we call a dilution problem, and here's the formula. The formula that we're going to use is the molarity of our concentrated solution, we're going to call that molarity of const, multiplied by our volume of whatever our concentrated solution, and that volume can be measured either in milliliters or liters, and we don't have to automatically convert it to liters like we did in those molarity problems. We can have it at milliliters, it's okay. Now that is going to be equal to our molarity of our dilute solution, or our weaker solution, or watered down, multiplied by our volume of our dilute solution. So we can use this formula to calculate unknown values, and that's what we're going to do next here. So once again, molarity of concentrated multiplied by volume of concentrated is equal to molarity of dilute multiplied by volume dilute, and they typically give us 3 of these 4 variables, and we just solve for the 4th. And let's take a look at a problem involving this. So we have a student with a stock solution that has a molarity of 6 molar. Right there, there's 6 molar H2SO4, that's sulfuric acid. Okay, now a student needs 500 milliliters of a 2.5 molar H2SO4. Now, here's the really important thing. One thing is, this 500 mils that's listed here, and I highlighted in blue, is tied to this 2.5 molar H2SO4. Okay, and what I mean by that is this. We can say that this is going to be our volume of our dilute solution, because these two values are tied together. This is going to be my molarity of my dilute solution, because 2.5 is less concentrated than our 6 molar. Our 6 molar is going to be our molarity of our concentrated solution. So we're going to use those ideas, and we're going to use the formula. Once again, the formula, molarity of concentrated multiplied by volume of concentrated equals molarity of dilute multiplied by volume of dilute. So it looks like what we're doing is we're solving for volume in milliliters of the 6 molar H2SO4. So we're going to plug these values in. So once again, our molarity of our concentrated was 6 molar multiplied by our volume of our concentrated equals our molarity of our dilute, which is 2.5 molar multiplied by our volume of our dilute, which is 500 milliliters, just like that. And so what we're going to do is we're going to solve this guy for our volume of concentrated. And by solving for volume of concentrated, we're just going to divide both sides by 6 molar. And molarity is going to cancel there and there. Now, on this side for our units, our unit of molarity is going to cancel with our unit of molarity. And then we're going to run these numbers through our calculator. Okay, so what I've done is run that through my calculator now, and that's going to give me 208 milliliters as my answer. Okay, and that 208 milliliters is going to be of our concentrated H2SO4, that's 6 molar. And so what we'll need to do is slowly add that to water to bring that up to 500 milliliters. Okay, let's take a look at our next problem here. Okay, and so our problem says if 100 mils of water is added to 50 milliliters of a 12 molar KCl solution, what's the molarity of the dilute solution? Okay, so these two values here, the 50 mils of the 12 molar are tied together. And then what we're going to do is we're going to add in 100 more milliliters of water, which was essentially going to dilute the solution down. So it's asking us to calculate our molarity of our dilute solution. Okay, so we're going to be using the formula molarity concentrated multiplied by volume of concentrated equals molarity of our dilute multiplied by our volume of our dilute. And so it looks like, what is the molarity of the dilute solution? We're going to be solving this value for the molarity of dilute. So let's punch in some values here. So our concentrated solution, it's 12 molar multiplied by 50 milliliters is equal to our molarity of our dilute multiplied by our new volume. Now here's the trick on this one. Our new volume is we're going to have to add these two values together. So our new volume is going to be 150 milliliters. I added 50 to 100. The reason why I have to add 50 to 100 is if we're adding in 100 more mils, then it's going to dilute the solution down. So now I'm just going to solve this for molarity of dilute by dividing both sides by 150 milliliters. And obviously they're going to cancel there. Milliliters is going to cancel there and there. And let's get an answer here. Okay, so now I have my answer, and it comes out to 4 molar, or a molarity of 4, and that's what's going on. Now I could double check this answer by plugging it back in. I could plug it back in right here, and it should equal whatever's on the other side. So if we did 12 times 50 gives me 600, or we could do 4 multiplied by 150, we get the same answer. So 600 equals 600. So that's the way we can double check our answers on these type of problems. And that's how we do molarity calculations, or excuse me, dilution calculations and we need to identify concentrated versus dilute based on typically the molarity.